Okay. Hello. I guess we can start. It's 10 past. So thank you very much for coming. My name is Adam Warski. I work at Software Mill. And today I would like to show mainly a live coding session of how we can transform code that is typically expressed using annotations to code that uses pure Scala code. So I have quite a long history with annotations. 10 years ago, I gave a talk at GeeCON as well about JSR 308. So that's a specification which allows you to put annotations on every type, so in even more places than I used to. So this actually ended up in being in Java. Nobody uses it, I guess. Almost nobody uses it, maybe luckily. So then I thought annotations were a great idea, but my approach changed over time. Last year I gave a talk also on GeeCON on called "What Have the Annotations Done to Us?" So I tried to explain why annotations might not be the ultimate answer to every problem. And this year I would like to show you a specific example on code, how we can replace a very common use case that is exposing HTTP endpoints, describing metadata on HTTP endpoints, and replacing annotations with code which we can manipulate. Okay, so first we will do a short introduction, and then we will jump to the actual coding. So let's go to slide 2. Yeah. So annotations have been with us in Java from 2004. So that's a really long time. That's since Java 5. They've been introduced to eliminate, and since they've been introduced, they practically eliminated XML programming, and that's certainly a good thing. If you remember mapping EJB beans, for example, in XML, that was a nightmare. So annotations have definitely been a great improvement into making the way we program business applications better. But they also introduced annotation programming. So in a way, we've taken the tool that the annotations are very, very far. And I would like to argue that we actually took it too far. So they've been a great step forward. But now we have even better tools that we can use. For example, functional programming is one such tool that is being discovered or rediscovered recently. So maybe there are some things in that approach that we can actually use to migrate from annotations to something that's hopefully better in a programming sense. So making code more readable, more maintainable, and so on. Slide 3. So annotations have a lot of good sides. So first of all, they are non-invasive, so you don't have to change the code that you're annotating to actually use the annotations. The metadata that the annotations express is clearly separated from the business logic, right? So you can clearly see what is the metadata part, so the annotation part, and what is the business logic part. They're also close to the referenced elements, so you don't have to look in a separate XML file, for example, to see how a particular method is described, so how an endpoint is exposed, and so on. And finally, they can be inspected both statically and at runtime, which gives them most of the power, right? So we have all the frameworks, all the containers which inspect annotations and do various stuff depending on that. But they also have some bad sides, right? So as I said, we've taken annotation usage to the extreme. So what we have right now, for example, Spring, which is, I think, the de facto standard of writing business applications in Java, it's in fact an annotation-driven container. Most of things can be, and usually is, expressed using annotations, right? So if we think about it, we in fact program the containers using annotations. So annotations have become kind of a programming language using which we program the container, right? It's as a language, annotations, they aren't really very type safe because they rely a lot of string references. There's like some basic syntactic validation that the annotation name is correct, for example, and the parameter is an int or a class, but that's about it in terms of type safety, right? So as a language, they are not really a type-safe language. They're an interpreted language because the containers interpret the language at runtime. So we have a non-type-safe interpreted at runtime language, which we use to express really a lot of stuff. Right? So on one hand, we have the powerful languages that we have today. We have Java, Kotlin, Scala, and so on. But somehow, we use this limited language of annotations to express a lot of the metadata that we use to describe our code. Right? So maybe we can use the core language to express the metadata itself. Because why not? Right? Why do we limit ourselves to this? Well, kind of a crippled language of annotations to express so much about our applications. So what we've ended up with by overusing annotations in a lot of places. So we definitely gained fast and convenient bootstrap. So if we want to create a new application, that's really fast. We just put a couple of annotations and it works, right? However, we've traded for that fast bootstrap. We traded a lot of certainty and control over how our application works. Like, for example, where the HTTP endpoints are exposed, what kind of entities our database uses, and so on and so on. So there is a trade-off here, right? So initially it's very fast, but as the application grows, we have less and less certainty and less control over what happens, when it happens, in what order it happens, and so on. So this also inhibits explorability of the code base, so it's harder to actually understand the code base once you read it. And there's a lot of magic happening. So, for example, the whole class path scanning, that's a lot of magic that's done by the containers. It's not really so easy or possible for a normal programmer like to go and see an application, understand like where, for example, the HTTP endpoints are exposed exactly in code, right? It's very hard to find that place. Partly due to the magic. And as I said, a lot of things happen at runtime instead of compile time, and I think we can actually do better. So the goal here, our goal here, will be to kind of bridge the gap, right? So there's a set of characteristics that we want to retain. So we want to retain the declarative nature of annotations. So we want to express metadata in a declarative way. We want to keep the separation of metadata and the business logic. And we want to keep the introspection capabilities. So we want to be able to introspect the metadata and interpret it in various ways. However, we also want to add a couple of things that are missing from the annotation representation. For example, type safety. Abstraction capabilities, like using annotations, we can't really abstract, we can't extract any common behavior or anything like that. We also can't compose annotations together because they're inherently non-composable. So we want to add these traits to our representation. And in here we want to actually use Java, we'll use Scala for two main reasons. Java itself, you could do it in Java, but in a very limited way, so you can't really get as much type safety as we would like. So we would use Scala because it has a more advanced type system, and it has a lot of it supports functional programming much better than Java. But don't worry, we will use only very basic Scala, so you don't need to know Scala to understand the examples. Don't worry if you don't understand every syntactic detail. So the goal here is to communicate an alternative to the way we actually do metadata programming in Java right now, not to learn you details about the Scala language. So I get the syntax is familiar enough if you know Java to read the code. OK, so I guess we can slowly. That's before we start. Also a short introduction, so you know who's talking to you. I'm the co-founder and a software engineer at Software Mill, which is a company which does custom software in a variety of fields. So we do blockchain systems, messaging systems, big data, and so on. Scala, Kafka, Cassandra Consulting. We are a remote company. We've been on the market for about 10 years. We are hiring, of course. We have a stand if you'd like to find out more about the company. I'm also doing some open source projects. In the Java space, I guess the one that's known is Hibernate Inverse. In the Scala space, a couple more, such as Tapir, which we'll be using here. Yes, and I have a Twitter account, which probably is not very surprising. And now we can jump to the demo. OK, so our goal will be to expose two endpoints. The first endpoints will be a listing of books. We want to get books filtered by the year of publishing and optionally limited to a given number. And we want to get a JSON array which represents these books. So the first endpoint that we want to expose will correspond to get/books. And now we will have two optional parameters. One will be year, the second will be limit. And we want to get a JSON list of books. So that will be the first endpoint that we will want to expose. So to do that, first we need to create a model for our books. So we will have a case class book. A case class is like a normal, it's like a data class, a normal class. However, all fields are immutable. You get equals hash code implemented. So it's like a class with all fields final and a constructor and so on. If you use Lombok, it's what you get with the add data annotation. So a book will have an ID. It will have a title and the year of publishing. And because working with date and time is always challenging, we will create a dedicated class for a year, just to make things a bit more interesting. So we will have a year wrapper, which will wrap an integer which represents the actual year. So we will represent here as a first class a value. OK, so now we have our model. So I also have some example books over here. So just so that I don't have to type them in. It's just some example data so that we have something to work with. OK, so once we have the model, let's now start describing our endpoints. So what we will do is we will create a value, which is an instance of a class, which will contain the metadata about our endpoint, right? So we are using the base language only. Here, the language is Scala. So everything will be in Scala, no annotations. But we want to keep the metadata separate from the business logic, right? So the metadata will be a separate value which will describe the structure of the endpoint. So the first value will be the get books endpoint. It will be an endpoint. It will be a value. And to describe the endpoint, we will use the Tapir library. Tapir is a library which contains the data structures with which we can model with which we can model HTTP endpoints. As in Java, you have, for example, the JAX-RS jar, right, which contains the annotations with which you can describe methods to map them to HTTP endpoints. Here we have a library which contains data structures to describe endpoints. So we will import the Tapir library, and we import all members from it. There's a number of helper methods which help you to describe things. So we start off with an empty endpoint. Endpoint is a value coming from the Tapir package that we have just imported. So this value describes an empty endpoint, an endpoint with no constraints, no characteristics. And then we will gradually build our description, defining more and more things about it. So the first thing is that this will be a get endpoint, right? So that's the method that we are supporting. And now we will define what are the inputs of the endpoint, right? So the first input, we are using the .in method to add an input, is that we require that the path is equal to books, okay? The second input is that there will be a query parameter, which will be an optional integer. And the query parameter name will be year. The second query parameter will be limit. So this concludes the inputs, right? We have described the input that there's a request method that must be equal to get. The path must be equal to books. And we have two query parameters. Then we have, if there's an error, we'll return a string body. And if the endpoint completes successfully, we will return a JSON body, which is a list of book. Okay, I will explain what these methods do in detail in a second. But before doing that, if we read this specification that we have written down here, if we read this, it's more or less in English, right? It's not maybe grammatical English, but more or less in English. If you read it even without knowing the library, I think you can more or less suspect what's the intention of the programmer, right? If we read that there's an input, which is a query, which is the name year, I guess you can suspect that this corresponds to the year query parameter, right? Same thing about out, right? You can see that the output is a JSON body, which is a list of books, right? So you can probably suspect that this endpoint, we are dealing with an endpoint since we have an endpoint over here, right, will return a list of books. Okay, so what we have created here is a value, right? That's a normal value. We can actually write that, we can run that code, and nothing will happen. The only thing that we have done is we have created an instance of the endpoint class, and that's it. Nothing happens yet. We can print line a nice representation of the endpoint, right? Because that's a value which describes the endpoint, so it knows all the structure, so we can serialize it as a string and find out what the endpoint is about. Okay, so what are these methods over here, right? So as I said, that's an empty endpoint, and then we gradually build the description. After each invocation of these methods, we get a new immutable description of an endpoint, right? So all the time we are working with immutable case classes, which we can with immutable values, which we can reuse multiple times. So, for example, the endpoint itself, it has 4 basic methods: .in for adding an input, .out for specifying what's the output in case of an error, and .errorout and .out for specifying what's the successful output, right? There's also a number of methods for specifying the request method. Now, these parameters here, for example, the query option and year, right? That's also a value. So the query method, this comes from the Tapir package. If you type tapir.query, you can see that it's a method in the Tapir package. And what this method returns is a description of an input, right? Again, it's an instance of it's a value. It's an instance of a class which describes the input, right? So all of the metadata is expressed as immutable values which we combine into a description, okay? So we can now take a short look at the class. So this value, this getBooks endpoint, is an instance of the endpoint class. The endpoint class, we can open it over here. That's the sources of the library. Again, it's a case class, so like a data class, right? An immutable data class, and it contains a couple of fields. So there's the input, for example, right? That's the description of the input. There's the description of the output in the error case, and in the successful case, right? So again, we can take a look at what is a description of an input. So we navigate to that. We can see that it's a sealed trait. A sealed trait means that it's an interface with a closed set of implementations that we can't extend anymore. So we have a number of implementations over here, and they model all possible inputs of an HTTP endpoint. So nothing very surprising, right? We have body, we have cookies, we have API key, and we have the query, for example, which we use here, right? So, for example, here we have a class which describes a query input for an HTTP endpoint, right? Again, it's a data class. We could create it by hand, so we could create a new query instance by hand by specifying the name. The codec over here specifies how to deserialize and serialize to a string representation. We could do it by hand, or we can use the helper method as we have done over here. Okay? So we are all the time we are working with values. So now let's create a second endpoint. So our second endpoint will be a getBook endpoint. So it will correspond to a get/book/ID, where the ID is a UUID, right? So this will be, again, we are starting with an empty endpoint. We are saying that it's a get, that we are using the get method. The path will be books/ and now we need to capture from the request UUID, which will be the book ID. Then on error out, we specify that we are using a string body, and on successful output, we are returning a JSON representation of a book. Right? Okay, so again, using more or less the same code as we have seen before. The important difference here is that we extend the path input. So before we were requiring that the path is a constant string equal to books. Here we see that the path needs to be a constant value of books, and the second segment will be captured, so it will be read from the request, and it must be a UUID, and it will be used as part of the input values for the endpoint, right? So now we have these two endpoints. Before we proceed any further, we can see that there is some repetition here, right? So some things are very similar about those endpoints, and in fact, probably if we in our application, if we had 10 or 20 of these endpoints, probably a lot of probably all of them, for example, would return a string on an error, because that's how we chose to represent errors, right? So maybe we don't want to repeat that in every endpoint description that we create. So what we can do? Well, there's a very well-known tool when we do coding. When we have repetition, we usually extract this as a method or as a value, right? So, and that's exactly what we can do here. Because we are working with values all the time, what we can do is we can create a base endpoint. This base endpoint will be the common parts of each endpoint in our library. So let's say our base endpoint will be an empty endpoint, right? All of our endpoints start with books, so they always are in the path always starts with books. So let's capture that, and they always return a string when there's an error, right? And these are the common parts. In a real life, maybe there would be some more common structure, but let's say that's our common structure for now. And now, when we have this base endpoint extracted, right, we can use it actually to simplify the definition of our endpoints, right? So, for example, we can take this endpoint, and instead of starting with an empty endpoint, we can start with our base endpoint, and we have the path over here and the error already defined, so we remove that. And same over here, base endpoint, we can remove the error and the path constraint, right? So we have extracted common parts of our HTTP endpoint description into a common value that we can use multiple times, right? It's an immutable value, so this value over here is immutable, right? So we can use it multiple times and multiple threads without any worries, right? And that's what we did here. So the second thing that we would like to do is we notice that we actually have a couple of endpoints, like in our hypothetical application, that read books. For example, maybe there's a search endpoint which accept the same kind of filtering, right? We always filter by year-end limit, and we don't want to repeat that filter over and over again, right? So let's actually extract this query, which is used over and over again, right? So what we can do, actually, as a first step, let's change this to a year. So we actually want to map this field as a year instance, right? So this won't compile. You can see that that's actually one of the features of type safety. Like here we want to map a query parameter to a value that's not supported out of the box, because that's our custom wrapper, right? So we have to specify how to actually map a string to this custom year instance, right? And the other way too. So what we have to do, and that's all checked at compile time, right? That these definitions are there. So what we have to do is we have to create a codec, a year codec. It's a plain codec for the type year. Plain codec because we want to serialize to text plain, right? If we wanted to write a JSON codec, we would write JSON codec. So a plain codec for year, and what we do here is we take the int codec and we map over it. So I'll explain in a second what happens here. Okay. So what we do is we take a codec for an integer, for a number, right? So this codec specifies how to serialize a number to a string, which is quite trivial, and how to parse a string into an int, which is also quite trivial. And once we know how to do that, we actually can map over it. And over here, we need to provide a function which converts an int to a year. So we just call the constructor. That's the constructor of our data class. And a conversion the other way around. So we need to say how to convert a year into an int. So we just select the year field, right? So we have created the year codec. Again, that's a value. But we have also marked it as implicit. That's a Scala feature which allows you to automatically use the parameter where it's required. So the query method over here, actually it has an implicit parameter list as well. And that implicit parameter list says that I need a codec for a year, right? And if there's a year codec, if there's a codec for the year class in scope, it will be automatically added by the compiler, so you don't have to do it. That's a particular Scala feature. You don't have to worry about it too much. We can see that it actually now compiles once we have defined that year codec. OK, so now we can continue extracting our query parameters. Just to remind you, we have noticed that, like in other endpoints, we are using exactly the same filtering. So we would like to extract the definition of the filter into a value. So what we can do is we can create a filter input, again, a value, which will describe our input, right? It will be a value describing that input. So what we do is we take the year input, and we combine it with the option of int input, right? And I can write down the type here. It will be of type endpoint input. The type will be a tuple, option year, and option int, right? So it compiles. That's nice. So what we have defined here is we have taken a description which maps to the query parameter year. We have combined it with the description which maps to the query parameter limit into a single input, which describes like a composite input, right? And that input, it maps to a type that is a tuple, right? Because we have combined two inputs. So it maps to a tuple that's a pair of these values, right? It will map to the request, which will, when given a request, it would extract both of these parameter values. So, well, that's good, but we can still do better. Actually, you know, this type, I mean, it's not really very descriptive. Like, what's an option of year and option of int? Like, reading this code, you can't really tell. So let's reify as a first class construct. So we will create again a case class, a data class book filter, and that book filter will have two fields. The first will be the year filter. The second will be the limit, right? So that's now a named concept in our application. So let's use it. So now you can see that the constructor over here matches our tuple, and we will use that fact. We'll call the map2 method, given the constructor, and here we have an input for a book filter. It compiles even in IDEA. OK, so what we did here is we have specified that the tuple, the pair of values, should be mapped to the book filter class, right? And again, at compile time, the Scala compiler will check that the book filter constructor matches these pair of values, okay? And it will actually now we will have an endpoint input which will yield a book filter value, right? So if we now read this code and if we take a look at the type, we kind of like suspect quite strongly what is actually what's the intent of the author, right? The intent probably is to express some filtering capabilities. And now we can use it as an input over here, right? So now we get quite a compact description of our input, saying that that's a base endpoint, right? It's a so like we know that the errors are a string, and on the input we get the book filter instance, and on the output we get a list of books. Okay, So that's all very nice, but one more thing that I might also show is what is the type of an endpoint, right? That's quite important. So we have seen the type of an input over here, and the type of an endpoint also isn't very surprising. So this value will be of type endpoint, and it will have a couple of generic parameters, of type parameters. The first type parameter is the value of the input that's extracted. So here it will be book input, book filter, sorry, right? Because that's the only value that we capture from the request, right? We use a constant path which doesn't extract any values, but we extract two things from the query parameter and we map it to our data class. Upon error, we return a string. Upon success, we return a list of books. Okay? So the type specifies exactly what's the input and what's the output of an endpoint, and we will use this information later as well. There's a fourth type parameter which relates to streaming, if you want to use reactive streams and streaming of bodies, but we won't use it over here. So that's the type. Again, the endpoint class here, we have seen before, we can navigate to it. That's the data class which describes the endpoint. Okay, so very nice. We have described our endpoint, but let's now actually do something with it. So the first and the most obvious thing that you can actually do with an endpoint is to expose it as a server, right? So to expose it as a server, well, it's not enough to have the metadata. You also need the business logic, right? So we will need to provide the business logic, but we will also need to have an HTTP server. Tapir itself doesn't contain an HTTP server. There's a lot of great implementations out there. So it integrates with a couple of them. So here we will integrate with Akka HTTP, which is an HTTP server built on the Akka framework, on the Akka library, which is an Acto library. So what we will have to do is we will have to translate the description of our endpoint into a presentation understood by Akka, right? So let's import the Akka integration. So that's a separate jar, a separate dependency that we have on our class path, Tapir server Akka HTTP. So import that integration, and that integration adds an extension method to our endpoint. So let's take the first endpoint, getBooks endpoint, and the integration between Tapir and Akka HTTP, as I said, it adds an extension method called toRoot. A root is it comes from Akka HTTP, and that's a data. It's like a structure, a function which describes an endpoint fully, both what's extracted from the request, the business logic, and how to send the response. Right? So it's a more complete representation. So now to convert the description of an endpoint, so we need to go from the Tapir world, from the pure metadata world, to a specific implementation of a server. So what we have to provide is the business logic, right? As you can see, IntelliJ tells us here that to convert this description of a root into this description of an endpoint into an Akka root, right? We need to provide a function which takes a book filter as an argument, right? That's the input. That's the input of our endpoint, and returns. Well, what do we have to return? We either have to return an error or success, right? And that's a very common thing in Scala and in functional programming in general, that you return either error or success, right? And to represent this, to represent returning either an error or success, that's the either data type. The either data type, if there's an error, is typically represented as the left side of the either. That will be a string, right? You can see here that the first type parameter is a string, which this string comes from the .error_out string body, right? Or if there's success, that's usually represented as the right side of the either. We get a list of books. Okay, so we'll write our business logic over here. We could also take a method from somewhere and just pass the method like a method reference, but I will write it directly here. So we take the filter, right? And now we need to actually do the filtering. So the first steps of filtering will be that we take the year filter. And if the year filter is defined, we took the books. So the books value is what I have copied. That's just a list of books, right? So yeah, I take the books, and I filter them by the publishing year, if the year is defined. If the year is not defined, I just take the whole list of books. Now the second stage will be to take the limit. If the limit is defined, then I take the first limit books. Otherwise, I get books 1. OK. So now books 2 is the value which contains the filtered list. And what I have to return, well, I always return success here. So I will always return the right side of an either, right? So I signal that that's a successful invocation of our endpoint, so I return a right. And I also need to wrap it once more into a future. HTTP is an asynchronous framework, so it always works with futures, right? Everything you do with HTTP, it always needs to result in a future, and we are no different here. If we integrate it with a different server implementation, the type here that we probably wouldn't wrap our results in a future, but something else. So we'll just return a future which returns a strict value. That will be our first route, get books route. So what we have done here is we have taken the description, the pure metadata, the value, the immutable value that describes our endpoint, and we have interpreted it, we have translated it from the metadata world to the HTTP world, right? In HTTP, you define routes, and a route contains both the mapping of what values to extract from the request. It contains the business logic, so what to run, what to do with those values, and how to return the response, right? So it's a richer representation, but also one which you cannot introspect, unlike the Tapir one. And in a similar way, we implement the getBook route, right? So we get the getBook endpoint, we call it to root. So here, the input is different, right? Everything is type safe. So the input is the ID of a book, and we have to return either an error or a single book, right? So again, we take the book ID, and we say that we take the books. We find a particular book where the ID is equal to book ID. Now, if we have found a book with that ID, then we return, again, a future, a successful result, right? So a right, an either right. And if we haven't found a book, then we return failure, so a left value, which will say book with ID not found. OK? So now we have two routes with book ID. Again, what we have done so far, we have just changed one representation to another. We still have to run the HTTP server, right? And in HTTP, this happens explicitly. So I will just copy some code over here, because it's quite boring code. So what we need to do is first we need to initialize a thread pool, which will be used by the HTTP server, right? That's the actor system. That's the thread pool which will run the actors. And which will handle the request. And then the most important part is over here, bind and handle. So we say that we want to bind to localhost port 8080, right? Everything here is explicit. So we have a specific place in code where we actually run the HTTP server. We pass an explicit set of routes that we want to expose, right? The routes here are the two routes that we have just defined. Right? So there's a specific place in code that we can navigate to and see where the routes are actually exposed. If we want to, we can navigate to all the details using standard IDE features. So if you want to understand what is getBooks route, we use go to definition, right? And we jump to the definition over here. If you want to understand what is getBooks endpoint, again, we use a very standard thing, which is go to definition. It's Appleby on Mac, but probably something different on other systems, and we can jump to that definition, right? If you want to see what is base endpoint, again, jump to definition. If you want to see which endpoints actually use the base endpoint, we do find usages, right? And we get 2 usages. So these are all very standard things, right? It's things that we do with our code every day. So when we have our business logic, we use go to definition to explore the code. We use find usages to understand the intent of the author and so on. So, and the same is here, right? So why should the HTTP endpoints descriptions actually use a different approach than we use for our business logic? So we can use the same tools to explore the code base and to understand it as we use with all other code. Okay, so let's see if it actually works. I'll write print line server started. So let's see if it will work. Let's try to run it. Okay. Server started. Terminal. Okay. HTTP 8080/books. And yes, we got a list, JSON array of books. We can filter it so we can limit the results and you get a single book. We can filter it by year. For example, which year? 1968, let's say. Yeah, The Art of Computer Programming. It's a book I guess everybody has on their shelves. Probably nobody read it entirely. So this works nicely. So what's next? Well, we have our representation of the endpoints, and one way to interpret them is as a server, but that's not the only way. Since we have all the metadata available, we can also interpret them in other ways. So one way to interpret this metadata is to generate a client, right? So we can, basing on a description of an endpoint, we can generate a client which will be used to actually invoke the remote endpoint. And another thing is to generate documentation. And we will do just that. So we will import integration between Tapir and OpenAPI or Swagger docs. So to do that, we need to import 2 things. First is an extension method which will actually convert an endpoint into an OpenAPI case class. An OpenAPI case class reifies the whole OpenAPI model. And then we need a way to serialize the OpenAPI case class into a YAML value. Okay? So what we will do now to generate the documentation, so the first step will be to get a list of endpoints, get books endpoint, and get book endpoint. So we create a list of endpoints for which we want to generate documentation. We call the extension method, which we just imported, to OpenAPI, and we need to provide the title, the Tapir library, and version will be 1.0. Okay. So now we have OpenAPI docs, and the type is OpenAPI. Okay, so this value here, so we have interpreted our metadata as an instance of an OpenAPI class. The OpenAPI class, again, it's a data class, and it directly corresponds to the OpenAPI or the Swagger specification. Okay, so now we can serialize it to a string. So we say docs to YAML. So now we get the YAML, and now we finally need to expose it. Swagger UI YAML.roots. Okay, so these roots that I have added here, these are roots which expose the static assets. So the images, the CSS files, and then the HTML files of the Swagger UI. So now let's run our example again. Okay. Server started. Let's open the /docs, right? Okay, so now we can see that we have the Tapir library. We have 2 endpoints as expressed in code, right? We can try things out. We can execute things over here. We can copy an ID, and we can try the second endpoint, right? So we can actually get a book with a specific ID, and yes, we got that book. we can try a book with a non-existing ID, and we get the error as we have specified, right? We can also amend the documentation. So for example, we might want to say that here we want to provide an example value of what is a JSON book. So we may say that in our, as part of our metadata, we want to add some description of the data structures that we use. So we can add a description over here. We can provide an example value. So we will just take the first book as an example, right? And now we regenerate the code. OK. So now we reload this. And if we go down here to the book, books, yes, you can see that there's no example here. Over here. That the example is here. So that's the first book from the list, right? And that's used as an example in our documentation. Again, if we wanted to reuse this input with the description, with the example, multiple times, we can extract it as a value and use it multiple times. OK, so that's for the demo. Now for some closing slides. Yes, before we conclude, just a short note about functional programming. So probably heard a lot of hype about functional programming, but you may have also heard that functional programming, is always about monads, functors, category theory, and so on. But that's completely not true. So in its essence, functional programming, what it's about is that you have functions and you have values. Usually these are immutable values, right? So we have functions which take some values and produce more values. The functions are values as well. So these functions can produce more functions, and that's it, right? So monads and functors are a very nice addition to that, and they help to actually tame side effects. But at its core, functional programming is really only about programming with functions, and that's it. And that's, in fact, what we are doing here, right? We are defining some immutable values. That's the endpoint class, the endpoint input class, the endpoint output class, and so on. So we have some values which we define. That's the description, right, of our endpoint. And then we have some functions. These are our interpreters, right? So we had an interpreter which allowed us to turn an endpoint into a server. We had another one which allowed us to interpret our endpoint as documentation, right? So we have values which describe things, and we have functions which work on these values. And that's a very common theme in functional programming in general. HTTP endpoints is just one example. Also, like in the Scala, Haskell, and other languages, quite commonly you describe things using immutable data structures. So for example, you describe concurrent operations, concurrent computations, or you describe how you want to interact with a database, or and so on and so on. And then you have various interpreters which actually run these things, right? But you get a lot of power by separating the description stage from the interpretation stage. So you first describe things as an immutable value, and you can manipulate these values just as any other value. Right? So you can use things multiple times. You can have functions which enrich these values, which manipulate those values, and so on. And then you execute them separately at some later stage. As for Tapir itself, it supports what you would expect. So all the parts of the HTTP world are supported. Things like paths, headers, cookies, authentication. You can interpret, as I said, using either to HTTP or to HTTP4S. But if you wanted to, you could interpret a description into a servlet as well, right? Into a blocking synchronous implementation. So it's entirely feasible. Nobody did it yet. And you can also interpret as documentation and as a client. So yeah, the main goal of Tapir was to keep the characteristics that we have when we define HTTP endpoint mappings in Java using annotations, but improve on that, right? Improve by adding type safety, improve by adding abstraction capabilities, but also at the same time being programmer friendly. So programmer friendly meaning that we have code which is easy to understand, easy to read, easy to explore. And yeah, there's of course, you could discuss if it's successful or not. I would be interested to hear your opinion. And one last thing before we finish. Next year, it will be the 10 years since Software Mill was founded. And as part of that, we are doing, first we are doing a tour of JAGs. So there will be software millers giving talks in various JAGs in various cities. And secondly, we'll have a party in spring next year. So you can win a ticket for that party if you go to 10thbirthday.softwaremill.com. You can actually fill a short form. I guess send an email. Oh, I have to connect so that the animation works. So yeah, so you can. So you can send us an email to get a chance to win a ticket. And there are also details on where on the JAGs we will be. And you can also, because finally we have an open source project after all those years, which has a nice name, which is an animal. So we couldn't resist, and we actually have now a mascot, which is a tapir, because all the previous projects, they had boring names, which didn't mean anything. So yeah, you can win this mascot at our stand. And yes, I guess that is it. Slide N. The project, of course, is open source. You can take a look. I don't think I have any time for questions, but maybe I can get a feed of all these questions, and I will just answer them and put a gist on Twitter with the answers. Would that be fine? Yeah, OK, so I will just get all the questions from Slido and try to answer them on Twitter. So yeah, so thank you very much for your attention.